Are you preparing for a system design interview and feeling completely overwhelmed? I get it. There's an ocean of information out there, and it's especially daunting if you don't have hands on experience with large scale systems. You're probably drowning in theory, trying to memorize a ton of concepts, and not really knowing how it all fits together. That's why in this video, we're going to focus on one specific part of the system design interviews. We're going to analyze the functional requirements. Now, you're like, functional requirements, that sounds extremely trivial, but bear with me. What we're going to do is we're going to break it down in a way that will help us throughout the whole design process. And so when you do this method, you really dig into the functional requirement and you start to see the DNA of the entire system. You'll uncover critical performance needs, you'll understand key trade-offs, and like honestly, it's not that obvious at first glance. So what this process does, it helps you just understand what the needs are for those requirements and why you're doing that. What I'll be covering in this video is only a subset of the full framework. If you find this approach useful, type "give me the guide" in the comments, and I'll send you the full framework. All right, so here's what we're going to cover today. You're going to learn 3 key steps to help you analyze functional requirements and create efficient system designs. Step 1, clarify the functional requirement. 2, identify key performance characteristics. 3, explore possible trade-offs. Step 1, clarify the functional requirement. So a functional requirement is a feature that defines what the system needs to do. So whether it's a feature for users or it's a feature for a system, in other words, what specific feature should this system provide or accomplish? And let me give you a few classic examples just to give you an idea of what a functional requirement is. Okay, so let's give some examples of functional requirements. The interviewer could say, here, design a search engine. And then the feature or functional requirement, the system should retrieve the top 10 most relevant search results based on a user's query. Or for a photo sharing platform, the system should store and serve images for user profiles. Or stock trading platform, the system should execute a stock trade immediately when a user clicks buy or sell, ensuring the best available price. So each of those functional requirements represents a specific task the system must fulfill. But to fully understand the functional requirement, we need to ask a few core questions. The first one, what problem does the feature need to solve? So this is identifying the primary problem that the system aims to solve for users. And you want to make sure that you understand this. It's crucial for designing effective features. 2, what inputs does the feature receive? This is going to identify what data or events the feature needs to process. 3, what output should the feature generate? This defines the expected results or actions the feature must produce. Let's go over some examples answering those 3 core questions to clarify the functional requirement. So for our search engine, the requirement is retrieve the top 10 search results based on the user's query. So, number 1, what problem does the feature need to solve? It needs to provide relevant search results based on users' input. So what input does the feature receive? It's going to receive the user search query. And what output should the feature generate? A list of the top 10 relevant search results. Let's go to the social media. User posts and retrieves comments. What problem does this feature need to solve? Allow users to post comments and retrieve existing ones. What inputs does a feature receive? Users' comment data and requests to retrieve comments. What output should the feature generate? Confirmation of comment posting and the requested comments. Let's jump down to stream video content without buffering. And this is for the video streaming service. So the first question is, what problem does the feature need to solve? Ensure smooth video playback with no interruptions. And what inputs does the feature receive? Users' video playback requests and network conditions. What output should the feature generate? Smooth video streaming without buffering. Okay, let's go to our next example, which is execute stock trade immediately on buy or sell. And so this is for our stock trading platform. So what's the problem that this feature needs to solve? Well, it allows users to execute stock trades at the best available price immediately.
What inputs does the feature receive? Users' buy and sell requests and stock price data. And what outputs should the feature generate? Executed trade confirmation and an updated portfolio.
So why is this step so valuable? Well, by asking these core questions and clarifying the functional requirement, you're not just defining what the system needs to do, you're also clarifying your thinking. And as you do this, you'll start to compartmentalize and make associations between different systems. So, for example, you'll recognize that a read after write request in one system's functional requirement might function similarly in another. And so this way, it doesn't feel like you need to memorize tons of different systems. You just start to see common threads that apply across various scenarios. Once we've clarified the functional requirement, the next step is to identify the key performance characteristics. This means figuring out how the system should perform under different conditions. And for any system, these are the factors that determine whether it runs efficiently.
Let's focus on 4 core areas. Latency, how quickly does the system need to respond? Throughput, how many operations should the system handle simultaneously? Scalability, as the system grows, how will it handle more users, data, or transactions? And accuracy, how precise do the results need to be? Okay, so let's have a look at our stock trading platform and use this as an example to help us focus on the 4 key performance characteristics. So for latency, how quickly does the system need to execute a trade? So for our stock trading platform, this means executing trades in real time, ideally within milliseconds. Throughput, how many transactions can be processed over a given time period? So during peak trading hours, the platform must process thousands of trades per second without delays. Scalability, as the number of users and trade grows, how will the system scale? The trading platform must handle more users and trading volume efficiently as it expands. Accuracy, how precise do trade executions need to be? The platform needs to ensure that users get the exact price they see or as close to it as possible, especially in a fast-moving market. All in all, to summarize, for our stock trading platform, the key performance characteristics are the system needs to execute trades quickly, handle a large volume of transactions, scale efficiently, and deliver accurate results. These key performance characteristics are essential for designing a system that can meet the demands of real-time trading.
So you might be wondering why we're jumping between functional requirements, performance characteristics, and trade-offs. Like, isn't it simpler to go from functional to non-functional requirements in a straight line? Well, here's the thing. Real system design, it's not linear, it's messy, it's iterative, and it requires you to constantly jump between different concepts. And that's exactly why we're approaching it this way. By staying intimately connected to your functional requirement while exploring performance characteristics and the different trade-offs, you're going to develop a much deeper understanding of your system. And this flexibility, it allows you to 1, anticipate challenges before they arise, 2, make informed design decisions, and 3, adapt quickly when requirements change. Think of it like this. You're not just building a system, you're creating a living entity that needs to perform in real-world conditions. So by constantly referring back to your functional requirement, and as you consider performance, trade-offs, you ensure that every design serves your core purpose. So this approach may seem chaotic at first. However, sometimes thinking non-linearly is necessary. Like, we need to do whatever we need to do to make sure that these concepts truly stick. So let's look at some common trade-offs that apply universally across many types of systems.
For each functional requirement, ask yourself these 4 key questions. Speed versus accuracy. How fast does this need to happen and how precise does it need to be? Throughput versus latency. Do we need to handle a high volume in a given time or prioritize quick individual responses? Scalability versus consistency. As we grow, can we maintain perfect data sync or do we need to compromise for scale? Accuracy versus throughput. Do we prioritize getting more done in set time or ensuring each operation is perfectly correct? So let's apply this to our stock trading platform example. Speed versus accuracy. Do we execute trades instantly to ensure a fast response for users, even if the price fluctuates slightly? Or do we prioritize locking in the exact price shown to the user, even if that means we might take more time to process the trade? Throughput versus latency. During peak hours, do we process as many trades as possible per second, even if the individual trades take slightly longer, or ensure each trade is lightning fast, potentially limiting total trades per second? Scalability versus consistency. As we grow, do we prioritize handling more trades across distributed systems, accepting momentary price inconsistencies, or ensure every user sees the exact same price, potentially limiting growth? Accuracy versus throughput. Do we focus on executing a high volume of trades per second, accepting a small margin of error in pricing, or prioritize 100% accurate pricing for each trade, potentially reducing the number of trades we can process?
Now you might be wondering, will this work with any system? And the answer is yes. Let's prove it by applying our framework to a completely different example, an ad server. Consider the functional requirement. Serve relevant ads to users based on their browsing history.
Speed versus accuracy. Do we serve quick, somewhat relevant ads to the user, or take more time to analyze all available user data for the perfect match? A faster response might mean less precise targeting, while a slower response could lead to more relevant ads. Throughput versus latency. Should our system handle millions of ad requests per minute, even if each takes slightly longer to process, or focus on delivering each ad in milliseconds, even if it means limiting the number of total requests we can handle at peak times? It's a balance between handling volume and maintaining speed. Scalability versus consistency. Do we prioritize handling more users and ad requests, even if it means some servers use slightly outdated user data, or ensure every server has the exact same up-to-date information, potentially limiting our ability to scale quickly? It's a trade-off. Serve more users or keep the data perfectly synchronized. Accuracy versus throughput. Should we serve a high volume of ads that are generally on target, accepting that they may not be perfectly matched, or reduce the number of ads served to ensure each one is precisely matched to user interests? This decision impacts the total number of ads served versus the relevance of each ad. This framework is designed to be universal, so whether you're working on a social media platform, a cloud storage service, or a stock exchange platform, these questions will help you uncover the key trade-offs you need to consider. Let's quickly recap the 3 steps for analyzing functional requirements. 1. Clarify the functional requirement. Understand exactly what the system needs to do. 2. Identify key performance characteristics. Determine how fast, scalable, and accurate the system should be. And 3. Explore possible trade-offs. Balance different priorities like speed, accuracy, scalability, and performance.
So if you found this helpful, do me a favor, make sure to subscribe and stay tuned for more videos. If you want the full framework, just add a comment saying, give me the guide, and I'll send it over.